to business now. I hope you remember that we still have class for the second half of the semester. Our class is on Monday 4 p.m. to 5 p.m. and on Wednesday from 11 a.m. to 1 p.m. Here, students are still joining. We have 38 students. But surprisingly, during test 1, we have 59 participants. During tests, we have 59, but then every week, class attendance is about 30 plus, 40 plus. So it means what? It means about 10 to 20 students have always skipped classes. And some, I think, have never attended any class before. So if you know who are there, so if they are friends, then please inform them. Please inform them. Please be aware that you have to attend classes in order to be qualified to sit for final exams. Okay, if your attendance is 0 or if you don't fulfill the requirements set by the faculty, then the faculty will not allow you, it will bar you from sitting for final exams. Right, so today I will move on to another chapter, new chapter, which is called short-term scheduling. So let's start by understanding what is short-term scheduling. Okay, I put slideshow. So the objective of short-term scheduling is actually to allocate and prioritize demand. Okay, demand can either be generated through forecasts or based on real customer orders to available facilities, machines, or work centers. Okay, so you need to understand that there are two important concepts here. First is allocate. Okay, allocate. Second is prioritize. So the objective of scheduling is to allocate. Allocate means assign. To assign. Prioritize means to determine the sequence. Okay, to determine the order. Okay, so to allocate and prioritize what? The demand. Demand here means the job to be produced. Okay, so the demand to be produced can either be generated through forecasts or it can be based on real customers' order. So we want to allocate and prioritize the job to be produced to the available facilities. Okay, facilities here means machines, work centers, workstations, or even workers. To let you understand what is allocate, let's say, for example, you have 3 jobs. Okay, 3 jobs or 3 products to be produced. And let's say you have several machines available. Let's say 3 machines. Right, so allocating means assigning which job to be produced in which machine. That's the meaning of allocating. So for example, this job to be assigned to this machine, this product to this machine, this product to this machine. So that is the meaning of allocating. Now, what about prioritizing? Let's say you have several products, several jobs available, but then there is only one machine available. So prioritizing here means determining the sequence of which product or job to be processed first. For example, this job may be processed first, followed by this job, and then followed by this job. So that is the meaning of prioritizing. So short-term scheduling aims to allocate as well as prioritize jobs to be processed or demand to the available facilities, such as machines, work centers, workstations, or even workers. So why short-term scheduling is important? Because effective and efficient scheduling can be a competitive advantage. Competitive advantage means advantage that will enable a company to win a competition. Okay, that will enable a company to outperform its competitors. So that is competitive advantage. So this competitive advantage is obtained through faster movement of goods through a facility. So it means effective scheduling will enable faster movement of goods through a facility or factory. So it means the goods can be processed faster with less waiting time. And this will also mean better utilization of assets, machines, as well as lower cost. And effective scheduling will also improve customer service. Customer service here means customer satisfaction through faster delivery or on-time delivery. And good schedules results in more dependable deliveries. Okay, more dependable deliveries means more trusted, more trustworthy deliveries. So if you have good schedules, then your customers will trust you more. So you can give more trustable or trustworthy deliveries to the customers. So now scheduling is not only applicable in factory. For example, in factory, of course, you have to schedule the production of goods, you have to schedule the workers and so forth. But scheduling is also widely applicable in the service sectors. For example, in airline companies, in airports, in hospitals, in university, and so forth. So, for example, in airports, in airline companies, they will have to schedule the maintenance of aircraft, right? For example, scheduling when to maintain their aircraft, how frequent to maintain their aircraft, and so forth. And departure timetable is something very important, okay, because this depends on the availability of the gates. In airport, there are different gates, right? So departure timetable depends first on the availability of the gates. It also depends on the arrival time of flight. Okay, sometimes a flight gets delayed, and when it's delayed, then the entire timetable has to be reshuffled. So all these factors have to be considered when we're doing departure timetabling for airport. And of course, in airport, we also have to schedule the flight crew members. We have to schedule the personnel working in the airport, such as the catering personnel, gate personnel, ticketing personnel, and so forth. Even in hospitals, scheduling is getting more and more important. Example, people in the hospital will have to do scheduling for operation room. Okay, normally every hospital has only a limited number of operation room. They won't have too many operation room. They have several or limited number of operation room. Right, and some operation requires longer duration, especially major operation, such as a brain operation or heart operation. But some operations are pretty fast; they require shorter duration. Some operation has to be done immediately, okay, because maybe the patient is in a very critical condition. But then some operation can be delayed. So all these factors have to be considered when we are doing the scheduling for operation room. Okay, and of course, there are other type of scheduling in hospital. For example, scheduling nurses who are on duty, scheduling the security staff, scheduling the maintenance staff, aircon maintenance staff, whatever. So all this has to be done, scheduling. And in university, I think you should be familiar. For example, classroom scheduling. Okay, which classroom is assigned to which subject or which course at what time, what date. Okay, we also have students timetabling, instructor or lecturer timetabling, schedule for graduate courses, undergraduate courses, and so forth. So I hope this gives you an idea that scheduling is not only applicable in manufacturing sector, but is also widely done in the service sectors. Now, if you look at the overall flow of production planning and control, if you look at this overall flow, I think I said before several times, normally company will start with forecasting and capacity planning. Okay, this is the first step that most company will do. And capacity planning is actually a long-term planning, which is done on a yearly basis. For example, you have just acquired a new facilities, you have just started up a factory, so the first thing you do is you have to plan your capacity. After capacity planning, a company will move on to aggregate planning. So I've already covered this topic before the semester break. So if you remember, aggregate planning is more of a mid-term planning, intermediate term planning, normally done on quarterly basis or on a monthly basis. Right, so if you look at the example on the right here, this is one example of aggregate production plan for making or producing bicycles. So this one is done on a monthly basis, first month, second month. And then if you look at this aggregate production planning, it's very general. It's general in nature. It gives the total production quantity for the bicycle. So in the first month, the total bicycle production is 800 units. In month number 2 is 850 units. So it's general because it doesn't specify which bicycle models. It does not specify which machine that you have to use, which worker you have to be assigned. So it's general. After aggregate production planning, a company will then do master production scheduling, or not or and master production scheduling and material requirements planning. And this is done on a shorter term, normally on a weekly basis. So if you look at this example, this is example of a master production schedule for making the bicycle. So now you see clearly now it is done on a weekly basis. The schedule is created on a weekly basis, week 1 until week 4, and then in month 2 is week 5 until week 8, and it specifies clearly which model. So for example, model 22, the bicycle model, model 22, you have to make 200 units in week 2 and another 200 unit in week 4 and so forth. So if you total up all this, it will be equals to 800 for the first month, and if you total up all this, it will be equals to 850 for the second month. Okay, and after this, the last thing, or as I said, maybe the eventual thing that the company will do is actually the short-term scheduling. Short-term scheduling is short-term, as the name suggests, it is short-term, normally done on a daily basis, or even hourly basis, or it is done every minute. So I already said just now, short-term scheduling deals with assigning work to specific facilities. So we are trying to allocate as well as prioritize the work to specific personnel and work centers. So for example here, this model number 22, if we do the short-term scheduling, it says that it is being assigned to be assembled or to be produced in work center number 6. So that is an example of short-term scheduling. Model 24 may be assigned to a different work center at a different time, and model 26 could be assigned to another different work center at a different time. Right. Now, if you notice, I have actually jumped from aggregate planning straight away to short-term scheduling. Right. Now, the reason is because there is something that you need to understand first. Okay, before I can go into master production scheduling and material requirement planning. So this week I will cover short-term scheduling. Hopefully I can finish it by this week. If not, it will go into next week. And after that, there will be another topic called inventory control. After inventory control, then only we will go into master production scheduling and material requirement planning. So I'm not skipping this topic. It's just that I need to teach short-term scheduling and inventory control first, then only I can teach master production scheduling and material requirements planning. Right, so scheduling deals with the timing of operations. I think everybody knows this. This is common sense. And the task of short-term scheduling is the allocation. As I said, it's the allocation and prioritization of demand. Okay, demand here means the job to be performed, job to be processed, or the product to be processed. There are some concepts here that you need to understand, which is called forward scheduling versus backward scheduling, finite versus infinite loading, and the criteria for sequencing jobs. So let me discuss this to you one by one. So let's start with forward scheduling. Now, forward scheduling is just a name. It's actually determine how we do the scheduling. So forward scheduling starts as soon as the requirements are known. Okay, for example, today is what, 9th of May, right? Today is 9th of May. Let's say a customer placed an order today, okay, 9th of May. Okay, and the customer requests the customer requests that the order to be delivered or the product to be delivered on, let's say, 31st of May. Okay, so that is the due date. To repeat, today due date that the customer requests the product to be delivered is 31st May, right? So since the customer has placed the order today, so it means the requirement is already known. So once the customer placed the order and the requirement is known, then we can start to schedule the production. So it means the production will start today. So this is what it means by forward scheduling. It starts as soon as the requirements are known. And this type of approach produces a feasible schedule. Of course, it produces a feasible schedule, although it may or may not meet the due dates. Okay, because it depends on the production time. Okay, it depends on the production time. So if let's say production time takes only 2 weeks. Okay, remember today is 9th of May. Due date, customer requests the product to be delivered on 31st May. Right, so if the production requires 2 weeks to be completed, so it means the production can be completed on 23rd, roughly about 23rd May. Okay, now if the product is completed earlier than the due date, then there will be two possibilities. Okay, one is the factory will ship the product straight away to the customers earlier than the due date without waiting for the due date, or the factory can actually hold the product first or store the product first in a warehouse, and then when it's come closer, when it is nearer to the due date, then only they will ship the product to the customer. Now, if the company decides to hold the product in the warehouse or to store the product in the warehouse, then holding cost will be incurred. Holding cost is storage cost. Okay, so this is something not good, because it will increase cost. So that's why if you use this approach frequently, it will result in the build-up of inventory. Okay, especially if the order or the job is completed much earlier before than the due date. Okay, now what about backward scheduling? Backward scheduling works like this. It begins with the due date in mind and then schedule the final operation first. And the schedule is produced by working backwards through the processes. Okay, so remember just now I said today is 9th of May. Due date, customer requests it by 31st May. Okay, production required 2 weeks to be completed. So if we do backward scheduling means we have to work backwards. We start from the due date, 31st May, and then we go backwards 2 weeks. Okay, 2 weeks from 31st of May is what? It's about 17, yeah, I think 17. Okay, it's about 17 May. So it means the company will only start production on the 17th of May. Okay, so the good thing about this approach is there will not be any inventory. Okay, because it is like a just-in-time concept. You start the production on the 17th May, and then you get it completed by 31st May, and then you straight away send it to the customers. So it's a just-in-time concept. So the good thing is there will be no inventory built up. But the problem is there is no safety margin. There is no safety margin here. Right? So this will be problematic if, for example, a machine is not available, or if a machine breaks down, or some other resources are not available. Okay, so that's why it says here resources may not be available to accomplish the schedule, and this will create a big problem for this type of backward scheduling. Okay, next. So because of that, in practice, you will see that very often these two approaches are combined. Okay, company seldom use a single approach. Okay, in practice, you will find that company will mix these two approaches. They combine these two approaches to develop a trade-off between capacity constraints and customer expectation. Right, so the next concept that you have to understand is this, finite versus infinite loading. Now, whenever I say loading, it means assigning a job to a machine, workstations, or workers, or in other words, allocating. So loading means assigning or allocating. So loading means assigning jobs to workstations. So we can have two types of loadings, finite loading and infinite loading. So finite loadings means we assign up to the capacity of the workstation. So it means assign the job only up to the regular capacity of the workstation. So if we do that, all the work can get done. All the work can be done eventually. Okay, but sometimes they may be delayed. Okay, sometimes we may go further than the due dates. Okay, because we can only assign the work up to the regular capacity of the workstation. So eventually all the job can get done, but then sometimes we may have to push the due dates even further. It means sometimes we may miss the due dates. So in other words, due dates may be pushed out. So that's the problem of this approach. And another approach is called infinite loading. Infinite loading does not consider the capacity of the workstation. So what does it mean? It means we can just assign, we will allocate work to the workstations without considering the regular capacity of the workstation. So what happens if the capacity is not enough? Then the company may have to find ways to increase the capacity. Okay, for example, by hiring more workers, by asking workers to do overtime, by buying new machines, adding new machines, and so forth. So the good things of this approach is all due dates can be met. Okay, for sure. We can meet all the due dates because if capacity is not enough, we have to increase the capacity. Okay, that's why I say capacity may have to be adjusted. Right, so as I said before, loading jobs means assigning jobs. Now, the purpose of assigning a job is to make sure that cost, the idle time, completion time are all minimized. Okay, that is the right way of assigning jobs. You need to assign the jobs to the right machines so that eventually the total cost, the idle time, and the completion time can be minimized. Two forms of loading, two forms of assignment. First is capacity oriented, which I already explained here, either finite or infinite. Or another type is assigning very specific jobs to very specific work centers. Okay, so assigning very specific jobs to very specific work centers. So that is another form of loading. And these are the criteria that we have to consider when we are doing scheduling. So whatever schedule we produce, make sure it helps to achieve all this. Okay, so that is like the bottom line, the bottom line that we want to achieve from the scheduling. So if you want to come up with a good schedule, make sure the schedule helps to minimize completion time. Okay, completion time means how fast the product can be completed. So the faster the better. So it means the shorter the completion time, the better. Second, make sure the schedule help to maximize utilization of facilities. We want the machines, work centers, employees to be fully utilized. We do not want them to be idling. Okay, because if the machines are idling, then we are actually wasting money. Right? So maximizing utilization of facilities. Third, make sure the schedule that we design help to minimize work in process inventory. Okay, I've said this before. If you have inventory, we have to hold it. Okay, we have to store it. So if we hold or store something, we need space. Okay, so when we need the space, it means we are consuming money. We are spending money to actually holding the inventory or storing the inventory. So this is something not good. So therefore, some companies try to minimize inventory as minimum as possible. Okay, actually, no inventory is better because you don't have to waste money storing inventory. Okay, but there is also a danger. If no inventory means there is like no buffer, no safety stock. So companies normally have to strike a balance, okay, between keeping the optimum amount of safety stock and at the same time minimizing the inventory in your factory. And fourth is minimizing customer waiting time. I think everyone knows this. Everyone, or I would say every individual, do not like to wait. Okay, because we get frustrated if we wait. Same with customers. So if you ask customers to wait, they will get frustrated, and next time they will not buy the product from you anymore. They will go to another company. So make sure the schedule we produce help to minimize customer waiting time. Right, let's look at some techniques. So now I'm going to the techniques. Okay, how we can do scheduling. So the simplest technique is Gantt chart. This is the simplest of the simplest. I think everybody knows what is Gantt chart. If you read the textbook, there are two types of Gantt chart. First is called a load chart, a Gantt load chart. And then another is a schedule chart, which is called a Gantt schedule chart. So a Gantt load chart actually shows the loading of the machines, loading of the jobs to the machines, as well as the idling time of the machines or facilities. And it also displays the relative workloads over time. So example is like this. This is an example of a Gantt load chart. Okay, so if you look at it, there are four machines. Okay, four machines, four work centers, and these are the day, working day, Monday until Friday. So if you look at metalwork, basically it is loaded on Monday. So this is what we call load chart because it shows the loading. So the work center metalwork is loaded on Monday to process job 349. On Tuesday, says the center is not available. Not available, probably maybe because of maintenance. The work center needs to be maintained. Okay, it needs to undergo maintenance, so therefore it's not available. And then again, it is loaded on Wednesday until Friday to process job 350. Okay, and then you look at the second work center. On Monday, it is unscheduled, means it is still available. Or in other words, it will be idling on Monday. And then on Tuesday and Wednesday, it is loaded to perform job 349, and so forth. So I think this is self-explanatory. I don't explain much. This is example of Gantt load chart. Okay, and what about a schedule load chart? I think you are familiar with this. Schedule Gantt chart, sorry, or call it a Gantt schedule chart. So a Gantt schedule chart actually shows the activities to be performed and the time required. So basically it's used to monitor jobs in the process. Okay, and actually all Gantt charts need to be updated frequently to account for changes. So example of a Gantt schedule chart. Okay, so I think everyone is familiar with this type of chart, right? So this is actually called a Gantt schedule chart. For example, you have three jobs to be performed, job A, B, and C, and you have day 1 until day 8. What happened? Okay. Let me stop sharing first. Let me find back the file. Okay, are you all still with me? Oh, nobody is with me already. Yes. Okay, I think something wrong with my computer. So give me a minute. I need to open back the file. Okay, I'm still waiting. Okay, if you notice, I'm actually running on Windows 11, not Windows 10. So maybe that has created the problem because the computer has become slower and slower. Or maybe I don't put slideshow. I think it's better without slideshow. Okay, so can you see the screen again? Can you see the PowerPoint slides again? No, can, huh? Okay, Alvin said can. Okay, so I think can, huh? Everyone can see, huh? So let's continue with this gun schedule chart. So everyone is familiar with this. Just mention the job, the task to be performed, and then the time required. Now, for example, if you look at this, it has a slightly different pattern that the gun chart that you normally see. Uh, this thing is called start of an activity, and here is the end of an activity. So if you see this sign here, okay, so it shows the plan duration for job A, starting on day 1 and then ending on day 6. And the one in brown color, I think light brown color, this is the actual work progress. Okay, so the black color line is the plan duration, and the brown color shaded box here, this is the actual progress. And pink color non-production time. Okay, so let's say now we are at day 5. Let's say now we are at day 5. At present, now we are at day 5. So let's say at day 5, which is now, at the current moment, what can we say about job A? Job A is actually behind schedule, right? Because we are already at day 5 here. Okay, but the actual progress is somewhere here only. So it means job A is actually behind schedule. Okay, what about job B? What can we say about job B? Job B is good, right? It has been completed on time, has been completed on time. So the actual progress is exactly the same as the planned progress. So it has been completed. So job B is good. And what about job C? The planned duration is until day 8. Actual progress is like until day 7. But currently we are only in day 5. So it means what? It means job C is ahead of schedule. So it means they perform job C very fast. Currently it is ahead of schedule. Okay. Okay. So far, any question? Joe miss anything during the interruption just now? No. Okay. So if no, then let's move on to another method. Okay. So this is another method where we can do short-term scheduling, especially assigning tasks or jobs to machines. So this method is called assignment method. It's actually a special class of linear programming models. Okay, linear programming models, you will learn it in a course called Operation Research, which you will take next semester. So there will be some repetition, okay? In Operation Research later, the course that you will take next semester, you will also study this assignment method. But then in more details, maybe looking at the mathematical models, formulas, and so forth. In this course, in this subject, PPC, I will only explain to you the steps of how to solve the problem without showing you the mathematical models. So this method is assignment method. Is a special class of linear programming models. The purpose is to assign tasks, jobs to resources. Resources here could be machines, could be workers, could be workstation, could be work centers. So I hope you understand. And the objective you're trying to achieve is we want to find the best assignment, the best allocation, so that eventually we can minimize either cost or we can minimize time. So either cost or time. So it means the data that we will give you is either cost or time, because we have to minimize this data, this cost or time. And the catch is this, the catch is only one job can be assigned to one machine. Okay, if you're talking about worker, then only one worker can be assigned to one project, or only one worker can be assigned to one machine. So it means there cannot be any overlapping. Only one thing can be assigned to one thing. Right, so let's look at this example. So this is given in the textbook. There are three jobs, job R, S, and T. And there are three typesetter available. So these typesetter are like workers. You know what a typesetter, right? Typesetter are someone that will typeset an article. Okay, for example, it will typeset a journal paper. It will typeset a book. So that is a typesetter. So you can understand this typesetter as workers. So there are three workers, worker A, B, and C. So the question now is, which job should be assigned to which workers? Or in other words, which worker should perform which job? Okay, which worker should perform which job, so that eventually the total cost or total time can be minimized. Right, so if you look at the data given, the data gives you the cost, not the time. So for example, to typeset job R, to perform job R, worker A charges $11. Okay, and if job R is performed by worker B, the cost involved is $14. If it is done by worker C, it's $6. So I don't have to explain now. All these are the meaning of all the costs here. So these are the costs. So which job should be assigned to which worker now? That's the question. So that at the end we can minimize the total cost. Now, if the problem is simple enough like this, I think you can already guess, right? You can already guess that, for example, job R should be assigned to job C because $6 is the minimum, right? It's cheaper, right? And then job S maybe should be assigned to worker A, for example. And then job T, you cannot assign back to C because C has already taken up job R. So maybe job T assigned to either job B or job A. Right? So what I'm trying to say is by just doing try and error, we can actually find the optimum assignment. We can do it. Okay, but if problems become more complicated, let's say you have more number of jobs and more number of workers, then the things become more complex. And this is where we can use assignment method. Okay, to find out the best assignment. So let's look at how the assignment method works. So these are the steps. I think you can read the steps. You can read the steps. I think it's better for me to explain how to solve it. So later you can read the steps. So let's look at how we can solve it. So these are given. This is given, as I said just now. These are the data given. 3 jobs, 3 workers, and these are the costs. So the first step is you have to do this. You have to do what we call a row reduction. First step, you have to do row reduction. Okay, row reduction means this. It means for each row, you find the smallest value. Okay, let's say this row. Let's say this row. Let's say this row. You find the smallest value, which is 6. Okay, and then what you do is you subtract this 6 from all the other values in this same row, in this particular row. That is called row reduction. So the smallest value is 6, right? So 11 minus 6 is 5. 14 minus 6 is 8. 6 minus 6, 0. Okay, and you repeat the process. Go to the next row, the second row. Find the smallest value. The smallest value is 8. And then you subtract this 8 from all the other values in that same row, in that particular row. So 8 minus 8, 0. 10 minus 8, 2. 11 minus 8, 3. And then move on to the next row. So you do it row by row. So go to the next row, find the smallest value. Smallest value is 7. So you subtract this 7 from all the other values in that particular same row. Okay, in that particular row. So 9 minus 7 is 2. 12 minus 7 is 5. 7 minus 7 is 0. Okay, now you may ask me why we have to do this. Now, the values calculated here are actually the opportunity loss cost. Okay, we call it opportunity loss cost or penalty cost. Okay, so let's call it opportunity loss cost or penalty cost. So if you look at here, if job R is assigned to job C, there is no opportunity loss cost or there is no penalty cost. Why? Because $6 is the cheapest. So if I assign it correctly to worker C, job R, if I assign it correctly to worker C, there will be no penalty cost because that is the cheapest that I can get. Okay, but if I assign it wrongly, let's say I assign job R to worker A, then I will have to incur an opportunity loss cost of $5, right? Because if I assign it correctly to C, I only need to spend $6. But now, because I've assigned it wrongly to A, I have to pay $5 more. Alright? So this $5 more is like a penalty cost or opportunity loss cost. Okay, same with this one, $8 here. Alright, if I assign R correctly to C, then I only need to pay $6. But if I assign it wrongly to B, I need to pay $14. So it means I have to pay $8 extra. So this $8 extra is actually the opportunity loss cost or the penalty cost. Right? I hope you understand. So all these values can be interpreted in the same way. So that is the first step, doing row reduction. Second step is to do column reduction. Call it column reduction. So same concept, for each column, find the smallest value and then subtract that smallest value from all the other values in the same column. Okay, so first column, smallest value is 0, right? Okay, so 5 minus 0, 5, 0 minus 0, 0, 2 minus 0, 2. Then move on to the second column, smallest value is 2, it's 2. So subtract 2 from all the other values in this same column. So 8 minus 2, 6, 2 minus 2, 0, 5 minus 2, 3. And go on to the third column, the last column, the smallest value is 0. So subtract this smallest value from all the other values in this same column. So 0 minus 0, get back 0, 3 minus 0 is 3, 0 minus 0, 0. Right? Okay, after that, move on to the next step. Okay, the next step is, okay, before that, so you understand all this, the values of all, the meaning of all these values, right? I already said these are penalty cost or opportunity loss cost. So actually, places where you have 0, places where you have 0 cost is the place where we can make the assignment. Okay, places that have 0 are places that we can allocate, that we can assign the job to the workers. So now, in the next step, you have to check whether this is optimum or not. Okay, so to check whether it's optimum or not, you have to draw the minimum number of lines to cover all the zeros. Okay, I repeat. Now we are checking whether the thing here is optimum or not. To know whether it's optimum or not, we have to draw lines, cover the zeros. So draw the minimum number of lines that can cover all the zeros. Okay, so you see here, I need 2 lines to cover all the zero, right? Now, of course, you can draw a line here, cover a 0, another line here, and then another line here. Okay, now this is not correct because I said the minimum number of lines to cover all the zeros. Okay, clear? So the minimum number of lines needed to cover all the zeros are only 2 lines. So the number of lines required now is different from the number of jobs, is different from the number of workers. So it means this is not optimum yet. If the number of lines is the minimum number of lines required to cover all the zeros are equal to the number of jobs or equal to the number of workers, then it is optimum. Understand? So the number of lines needed to cover all the zeros must be equal to the number of jobs, which is 3, or the number of workers, which is also 3. So in this case, only 2 lines. So 2 is different from 3, right? So it means this is not optimum yet. So what do? We move on to the next step. Next step is, look at here, next step is you have to find the smallest uncovered number. The number in this table which is not covered by the line. So the smallest uncovered number is 2. So what you do with these two is, first you have to subtract these two from all the other uncovered numbers. So you have to subtract 2 from 5, you have to subtract 2 from 6, you have to subtract 2 from 3. Okay, read here. Subtract these two from all other uncovered numbers. And add back the value, add back the 2 to the numbers at the intersection of the lines. Right, so intersection of the line is here, right? So we have to add back 2 to here, to this point, to this place here. Okay, so repeat. Find the smallest uncovered number, which is 2, and subtract this smallest number from all the other uncovered numbers. So 5 minus 2, you get 3. 6 minus 2, you get 4. 3 minus 2, you get 1. Huh? And then add the 2 to the place where the line intersects. So 2 plus 3, you get 5. Okay, the rest you don't change it. So this one remain as 0, this one remain as 0, this one remain as 0, this one remain as 0. So once this is done, then we can check for optimality again. We can draw the number of lines to see how many lines are needed to cover all the zeros. So how many lines are needed to cover all the zeros now? The minimum number of lines. Okay, anyone? 3.
3, Doctor.
Okay. So 3, no matter how you draw the lines, you need 3 lines. Correct? If you draw like this, 1 line. If you draw like this, also 1 line. If you draw like this, 1 line. So total 3 lines. Right? Or you draw like this, 1 line, 2 line, 3 lines. No matter how you draw, you need 3 lines. Or you may say I will draw like this, 1 line, another line, another line. Also 3 lines. So it means the minimum number of lines required is 3 lines. So 3 lines, so 3 lines is 3, so 3 equals the number of jobs, which are 3 jobs, and number of workers, 3 workers. So it means this thing now is really optimum. Right? So if this is already optimum, then we can start to make the assignment already. Okay, remember, places where you have zeros are places where you can make the assignment. Right? Okay, so which one should be assigned to which now? Okay, look at the table over here. This table I already explained to you. Look at this table here. So job R should be assigned to job worker C. Job R should be assigned to worker C because we have 0 here. Okay, and what about job S? Job S can be assigned either to worker A or B, right? Now, it cannot be assigned to worker A, because if you assign S to worker A, then job T will have a problem. Because job T cannot be assigned to worker C already, because C has taken up job R. And T cannot also be assigned to worker A, because A has taken job S. So it means what? It means S cannot be assigned to A. S can only be assigned to B. So job S is assigned to job B, worker B. And finally, job T, as I said, job T has only 2 options, either A or C, cannot be assigned to worker C because worker C has taken up job R. So it means job T can only be assigned to worker A. Okay, got it? So it means the optimal assignment now is job R is assigned to worker C, job S is assigned to worker B, job T is assigned to worker A. Anyone does not understand? No, I think it's simple, right? Think about this, I think it's simple. So this is why I said R assigned to C, S assigned to B, T assigned to A. So this is our original data, the cost. So if we have this assignment, then the minimum cost will be $6 plus $10 plus $9. Right? So that is actually the best assignment that will give us the minimum cost. So $6 over here, plus $10, and then plus $9. Okay, following this assignment. And total cost is 25, which is the minimum. And please understand, one job can only be assigned to one worker or one machine. There cannot be any overlapping. And because of that, you will see that the number of rows must be equal to the number of columns. Right? If the number of rows is not equal to the number of columns, then we may have to add dummy columns or dummy rows. Okay, as I've explained before, I think before the semester break. Okay, today I've overshoot the time a little bit. It's already past 5 p.m., so I think I should stop here. I will continue on Wednesday at 11 a.m. So, question, if you have any. Okay, if no, then we stop here. Later, as I said, after 5 minutes, you can scan your attendance. So, goodbye and have a nice day. See you on Wednesday. Bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you, Doctor.
Doctor.